Hello, this is Dr. Muhammad Ali. Today I'm going to talk to you about FPGA. What is FPGA and how can you program FPGA, and what is the application can be really benefit from FPGA. Okay, so FPGA stand for Field Programmable Gate Array. Okay, and it's actually, if you go into the chip of the FPGA, you will find it's like a box. It's surrounded here by RAMs, and it's called BRAM, block RAM, and the outside world can communicate to the inside world using the pin, and this pin can be assigned to be input or output or high impedance. And I mean by high impedance that is not connected, or maybe can be connected for a different purpose. Okay, inside the box you will find a couple of small tiny blocks. Each of them is called CLB, and CLB is configurable logic block. Okay, those can connect it to each other using connectors or wires. Okay, and I want you to think about FPGA as it's like a big box of toy Legos, and when you will connect them in a certain way, you will have a different shape. Okay, so if you have a four of these Legos and you connect them together like that, you will have a square. But for instance, if you just like remove one of them and connect it like that, it's gonna be a triangle. Or maybe if you can just like move it somehow, it's gonna be a circle. So it's very flexible. It is flexible in a way that you will be able to implement digital circuits in a different way. Okay, it's not like that traditional way, use fabrication and layout. And actually the traditional way is stand for IC, integrated circuit. Okay, so inside each of this CLB you will find something is called a slice. And this slice is actually, you already have the CLB here. CLB, it has here two pair of slice, another two pair of slice, one for the horizontal and one is the vertical, and they connected to each other using a switch or matrix switch. And then this is gonna be connected to another CLB, this CLB, and this is called slice. Inside the slice you will find a couple of look up table, LUT, and flip flop and max. What is those for? Okay, and what is what we are mean by why we mean by those things, right? So LUT, lookup table, it can be used for storing data. But the flip-flop, it's actually a way of generating a synchronization on the circuit, or in a way you're causing delay, and that delay will be able to synchronize signals. So for instance, let's say somebody came early morning and he sat until the other guy he came after him was 10 minutes. The chair used to keep this guy sitting until the other one came into the room, flip-flop, because you're just like he was waiting, right? And then the multiplexer, you can think about the multiplexer like you're like, for instance, the stop sign, right? So the stop sign, let's say we are coming from two different way, and then we have to go in that way, right? So we have to have a certain sign say, oh, car A should access the road and then car B will access the road, right? The same thing like multiplexer here. Multiplexer, you already have two input, A and B, and the output will be C. And here is the selector, which is the signal, right? The traffic signal. When this goes high, C will equal A. When this go down, C will equal B. Okay, so all of these small items we can be used to build a bigger picture, like for instance processors and arithmetic logic unit, which is adding and subtract and multipliers and stuff like that, multiplications. And it can be even used for SoC system on a chip, and it can be used for many different things. A lot of that can be beneficial for the bigger pictures, like application, like for instance on the broadcasting, right? So in the broadcasting, the receivers can have a lot of FPGA connected to each other, and those can be able to, when you stream a signal and you would like, for instance, to encrypt or decrypt the signal based on if the customer gonna pay the fees or not. So nowadays you just call in the phone, for instance Comcast, and they'll say, hey, I would like to access, for instance, Showtime. I'm gonna pay this amount of money. They are gonna send a signal to your receiver, and based on this signal the receiver will decrypt the channel, and you will be able to watch the channel. Okay, so this is one of the application can be used for. Or medical applications. Medical application can be used for, like, you know, monitorings and stuff like that, for instance like Fitbit, Apple Watch and stuff like that. It can be used for space applications, especially, you know, think about it. I already built a robot or rover, and I would send it over like to another planet like Mars or whatever, and then, you know, I would like to change the bunch of commands I already sent to the rover, and instead of sending a new rover using ASIC, which is IC circuit, which is gonna be really expensive, I will have a more flexible circuit which I can send bunch of signals from the Earth. It will change the behavior of the circuit. Okay, so that's one of the things about FPGA. And video processing, signal processing, many other applications. Okay, and even, you know, even though, you know, you can implement GPU in FPGA, and even you can implement, as I said before, processors, or you put different things, or maybe you can make text match, like, you know, using this non-deterministic finite state machine and deterministic finite and automata and whatever, right? How can you use FPGA? There's actually two big vendors playing in the market of FPGA. One is called Altera, which is recently bought by Intel, and Xilinx. Okay, I already have here at the moment many boards. I can show you, for instance, there is here a board. It's called Z board or Z board, which is like based on zinc, and this has SoC, system on a chip. Okay, and then, you know, I already have the earlier version of FPGA, which is called CLBD, programmable logic device, which has been made also by Xilinx. It's called Cool Runner 2, which is actually be able to be programmed using ISE. What is ISE and what is those things for, right? So let's talk about Xilinx. Okay, Xilinx, before, you know, you have to use a program, it's called ISE, for translating your design or the descriptions you already have into the FPGA, and then they already have a new version of this. It's called Vivado. So how it works? So first, you already have a bunch of spec. Let's say I would like to implement equation. It says y equal x plus c, right? So I would like to describe this equation. I can describe it using high-level synthesis language, or I can use it for instance C. I would just say y is equal x plus c, and then, you know, I will say integer x and int c or whatever, and then I will say printf y, and then I will say it's maybe decimal or whatever, right? Maybe, and then, you know, the tools Vivado, HLS, high-level synthesis, will convert that into the hardware language Verilog or VHDL. The other way is to implement the behavior of the equation using RTL language like Verilog or VHDL, which is like, you are gonna have adder, and this adder has two input. One is called X and one is called C, and the output is gonna be here Y. Okay. Then second part, when you will design that, you already have to define where is the input and the output on the board. Then thanks God that we already have the XDC file, which you define and say X is gonna be bin number 4, for instance, and C is gonna be bin number 5, and then Y, for instance, is gonna be bin number 7. And then already you have on the chip, you already have oscillator, and this oscillator used for generating a frequency. Okay, let me show you examples about how can you use it. I already have here at the moment BSES 3 board, which is I have at the moment 3 examples I can show it to you. Okay, so if we go here on the computer, I already have here the board which have been made by DigiLens, and this board, it has different peripherals, as you can see, bunch of set of switch can on and off, a couple of LED here, and 7-segment display, couple of push buttons, and PMOD. And PMOD can be used for attaching different sister boards, okay, like extension boards. So let's say I'm gonna use a very simple example here. I'm gonna run my machine, and the machine here, it will have Vivado. Vivado is running here. Yeah, so I have here Vivado. So I will say here, close the project, on the project, and then say here, open a project. I save it here in example 1. So you will go here. I already generate the bit file, so we don't need to generate it, and say here open target and device, and you run. Okay, so if you see here, I connected the computer to the board using through the G tag from this side and USB from the other side. Okay, now I already upload the bit file, which can actually mapped on the FPGA, and based on that we will be able to see what's going on here. I would like to write on the 7-segment display, for instance, a year burst of somebody, let's say 1983. Okay, so I already have here, I assigned 4 switch for each segment, each digit, sorry. So let's say 3 1 2 and then 3 4 0, and here I just like I made the LED here turn on and off to see the binary action of that. So here I already have 3 and 1 1 2 3 4, and then we said here 1 2 3 4, so 8, and then and then we said 1 and 1 1 2 1, and then 1. So it's 1983. Okay, the other example I can show it to you, it's more and more actually complicated, right? Which is how can we build a counter can react as a jump command on assembly. So for instance, in assembly you already have a bunch of instructions, and then in the instruction you say jump to 7. That means you have to go in a certain location and start over and over until you see jump and back and forth, right? This is exactly like a counter. When you will assign the input a certain number, you will jump to that point, okay, and then you will start counting. So we are gonna close the project here, close the project, and open a new project, which is showing what I'm saying here. It's gonna be example number 3, and here, and then tools, flow, open target here, and then open the right and run. So if you see here what's going on here actually is going that I'm trying to check to feel what is the difference between low frequency and high frequency. Okay, so if you're in a high frequency, the counter will count and your eye will not be able to recognize that the counter is counting. So we see that it's like, stop somehow, right? But if we slow down the count here, I can see the actual count is counting, right? Another part of that, which is, as I mentioned before, like a jump. Let's say, I'm gonna write 3 and I would like to start from 3. So I already assign here 3 and then I push here, so 3, 4, 5, 6. Let's say I would like to start from 7. So I would say here 7 and I start from 7, 7, 8, 9, 10. The last example I have today is actually about how can we use the system board for writing Welcome Virginia. Okay, so here we open LCD example. Here is the LCD example. We already have the system board. I'm gonna attach this board to the PCD, as you can see here, and then I'm gonna upload the file into the board, and a second for that. Shut by itself, but it's not a problem. We can just run it again. So here Vivado. So I'm trying to control the system board from the BMOD. Okay, so once we will upload the stream of the bit file on the FPGA, the FPGA will react based on that. Okay, so here open projects, LCD, file, open, run it. Okay, so nothing happened. That's really weird. I'm not sure what exactly happened, but it seems that unpleasant reaction is going on here. It might be something wrong with the system, but let's see what's going on here. Yeah, I think the board is not working, but that's fine. But anyway, the only example I have now is running. Maybe is let me see what's going on here. Maybe it's something silly happened. We can just like run the tools while we are talking and sum it up. So what's going on here? So far we talked about FPGA. FPGA can work as a toy box, help you to be able to implement different architectures, and for the open house thing, you have to know that computer science department and ECE, which is electrical and computer engineering department, both almost the same. So they are almost the same. They are cooperating and integrating to each other. They are trying to help each other. Computer science more like end-to-end tools and software levels, and even running on different application. FPGA, for instance, can be used for high-level application like big data and stuff like that, by using many of this FPGA running in parallel. Actually, taking the advantage of FPGA, which is can you implement multi-thread or like for instance many processes running on the same chip at the same time, using the flexibility we already have. Of course, the FPGA doesn't have the speed as the ASIC or the integrated circuits, since it can be run to 1 terabyte, but the ASIC is not that flexible as FPGA. And nowadays FPGA Xilinx Vertex 7 can run up to 800 megahertz. Maybe in the future the ultra scale can run for 1 gigahertz or something like that, which is not bad for the flexibility we have on the FPGA. And maybe the board can work now. I'm not entirely sure what is going on. Maybe it's something happened on the board, but in all cases it should work and run the examples we have. Maybe you can just give it a shot for 1 minute and see what's going on here, because this is the tool here in front of you, Scope Vivado, and we are trying to run it now. I think I'm generating the bit file. Maybe the bit file is corrupted, but let's see. That can actually happen. So let's see, open hardware manager, remind me later, target, auto, run. Yeah, I think some damage happened. But anyway, that's what we have at the moment today, and I really would like to thank you for listening to the talk. And if you need any help, just let me know, and I can write down to you here my contact, which is like here is MEA4C at virginia.edu, or HADEDY at illinois.edu, and my phone number is 312-566-3128. And you are welcome to come with any questions, and I'm gonna help as much as I can. Thanks a lot, and have a great day. Thank you.